So objective 28 is going to be the same absolute value inequalities, but your answers will all be graphs. So it won't be just the answer, it will always be the graphs. But there are some tricks to knowing what these graphs look like. This very first one that you have, this is an absolute value. What is that? This is a mumbling. Greater than or equal to. This, whatever this sign is, makes a huge difference how you approach this problem. If this is a less than, Keaton, what are you going to make? Every time I point to you, you just say the same thing you said earlier. What are you going to make?
Three-headed dragon.
Three-headed dragon. If it's a greater than, you're not doing that. You're doing two different problems. So start by solving it. Recall that absolute value greater than means make two different inequalities. Two different inequalities, and we put an or between them. That was on the notes yesterday as well. What's the first one going to be? Absolute value x is greater than or equal to 3. Give me one of them.
X is greater than or equal to 3.
Sure. X is greater than or equal to 3. I'll put that right here. What's the other one?
X is less than or equal to 3. Negative 3.
Negative 3. So there's your 2. You take this 3 and say, all right, less than or equal to the negative 3, greater than or equal to the regular 3. And then you graph both of them. It's an or problem, so I don't care about overlap. They both get to come on the line, and they both get to be a part of the answer. Less than or equal to negative 3 means a solid dot at negative 3. In which direction do you go?
That way.
And by that way, I'm hoping you mean this way. And then the other one is a solid dot at regular 3. And which way do we go?
The other way.
The other way. There we go. So take note. You just did an absolute value greater than problem. A very simple one. Look at your two dots and your two arrows. Anytime you've got absolute value greater than, you're going to have dots with arrows going out. So when you have absolute value greater than, what can you expect? Arrows going out. It makes it simple if you know what to expect, especially if you have multiple choice problems. If I see absolute value greater than, and I see dots connected, I'm going to think no. I'm going to think I want dots with arrows going out. All right, this time, instead of just x, we actually have like some junk inside the box. You got x plus 4. But we still have to go, this is absolute value.
That's x plus
What's
1.
the, oh yeah, x plus 1. What's the sign though? Greater than. You work them all out the same if they're greater than. Split it into two inequalities. What's the first one?
X plus 1 greater than 4.
Well, yeah, I'll do that one over here. X plus 1 is greater than 4 over here.
X plus 1 is
Less than negative 4. So you say this stuff is less than negative 4 and this stuff is greater than regular 4. And then because it was more than just an x in there, you have to work them both out. So minus 1, it looks like x is less than negative 5. Or minus 1, x is greater than 3. Both of these will be the same type of dots. When you break it up and it doesn't have the equals to, you don't have the equals to on these guys. What's this first one? It's going to give you a dot where? Negative 5. What kind of dot? Open dot. And where does it go from there? All right, this one gives you an open dot at 3, and you go right. So once again, absolute value greater than gives you what?
Oh, it's going away.
Yeah, the two dots, the two arrows going away from each other. That's a common theme on absolute value greater than. You've seen two of them. Both of them had arrows going away from each other. Now this one, more difficult because you have a bunch of junk here and here. What are you supposed to do with that stuff before you do the breakdown?
Isolate.
Isolate the box. Get it by itself. So, take care of this first. What do we do? Plus 1. And now 2 times 2x plus 1 is greater than or equal to 6. You're still not isolated because you still have this 2. Think of this as like your variable is the box. How do you get that 2 off? Divide it off. And now you're going to have a 3. Divide. And you're going to get 2x plus 1 is greater than or equal to 3. Now I'm running out of room. I'm sure you're running out of room as well. We got to get it done on this. So the first, let's just put them over here to the left and right. First one, 2x plus 1 is less than or equal to what? -3. 2x plus 1 less than or equal to -3. 2x plus 1 greater than or equal to regular 3. Solve both of these. Solve both of them. -1. 2x is less than or equal to -4. Divide by 2. -2. There's one part of it. On this one, you get 2x greater than or equal to 2. X is greater than or equal to 1. So I need dots on -2 going left and dots on 1 going right, Tyler.
Could we, before we split it into 2, could we take the 2x away so it would just be a regular x? Or would we have to leave 2x there?
Well, the problem is you can't just divide like when we had 2x.
Yeah, like before we broke it into 2 separate problems.
Well, you'd have to divide this by 2 and that 1 by 2 and that 3 by 2.
Gotcha.
So it would kind of get you fractions all over the place. You can't just say, hey, just divide this by 2. It's this and this and that.
Okay.
So, but usually once you break it into 2, it's usually a 2-step process. It's the add or subtract and then the divide. So 2 steps on this one, 2 steps on that one. And we got a solid dot at -2. Where's that dot going? Left. You got a solid dot at 1. Where's that going? Right. 3 straight absolute value greater than problems have looked like this. Arrows going out. Absolute value greater than. Arrows going out. Now the whole back page is going to tell you about absolute value less than. Starts off more complicated. We've already got past the basics. First thing I need to do on this one is what? Isolate. So I do that by doing what? Minus the 1. We need to isolate this box by itself. So I need to get this 1 off of it. Absolute value of x plus 2 is less than or equal to 4. This is an absolute value inequality. It's not an absolute value equation, because that's not an equal sign. It's an inequality. Depends on what this is as to what you do. What kind of inequality is it? Less than. Keaton, when we have a less than, what do we do?
3-headed dragon.
3-headed dragon. And by 3-headed dragon, I mean drop yourself in 2 of these. What's going to go on the far left? -4. What's going to go on the far right? 4. Positive 4. And what goes in the middle of the dragon? The head of the dragon is? Okay, solve this up. Here's the good thing about this. There's no coefficient on x, so you don't have to do any dividing. All you got to do is, what? -2 everywhere and you're done. -2, -2, -2. -6, x, and 2. All right, a 3-headed dragon will always graph the same way. This one from last week, even before we did absolute value inequalities, we talked about the 3-headed monster, the 3-headed dragon. It's the 3-piece inequality. It is 2 dots that do what? Connect. I need a dot at -6 and a dot at 2. The x is in the middle because that means shade between these 2 numbers. I'm telling you -6 and 2, and x is between them, shade between them. That's how all 3-headed monsters, all 3-piece compound inequalities work. -6 and 2, and we connect it. And I chose to use solid dots. Why? That would have been better if you would have answered it first, and then it was like cue music. Because of the what? The equals 2 underneath them. All right. For some reason, I went easier on example 5. It's already isolated. So if it's already isolated and you have absolute value less than, three-headed dragon. So, by three-headed dragon, I mean drop in two of these. So you got three sides. The farthest left is what? And the farthest right is? And what goes in the middle?
I meant
X plus 8.
A lot of eights.
A lot of 8s. Now when you subtract 8s from this, we end up getting what on the left?
negative 16.
Less than,
X.
less than. And that's fine. That means you've got a dot at negative 16, which is why I drew the graph the way it is. What kind of dot though?
Open.
Open. You got a dot at 0. Open. And what do we do? Just between them. There was some confusion about some people saying, hey, if we just have these less thans, why doesn't this thing just go forever left? Understand that what you're looking at here on the three-headed monster is that it's different than just a regular less than or greater than. That's why it's called a complex or compound inequality. You're going to go from negative 16 to 0, and the x represents that we're shading in between them. All right, observe what happens when we have absolute value less than or equal to, greater than or equal to. When we have absolute value less than, what did you notice with its graph? The two dots connected, right? The back side, we're both our absolute value less than. Two dots connected and two dots connected. So if you have an absolute value problem, what do you expect your answer to be? Two dots connected. I would imagine if you were doing one of these problems on your work, if you have an absolute value less than problem, two of your answers probably have connected dots. And two of your answers probably have arrows out. It would make life way simpler if you just remembered absolute value less than, connect the dots. Absolute value greater than, what happens? Arrows going out. Arrows out. The first page was all absolute value greater than. And if you look and if you remember, arrows out, and arrows out. All right.